In this video, I'll be covering question 5, part D from the 2021 AP Calculus AB free response no calculator allowed portion of the test. If you want to see A, B, and C's answers, you can see those in their own separate videos. This video is just going to be talking about part D. So let's dive in. They want us to determine whether F has a relative minimum, a relative maximum, or neither at the point found in Part C. So if you didn't watch Part C's video, I can just go ahead and get you the punchline for that. The point we found in Part C was pi over 2 comma 2. So we found that was where there was a line to the curve that was horizontal. So this is really what we found here was a critical value. Then when you see the terms relative max and relative min, kind of the first thought that should pop into your head is first derivative test. The unfortunate part about this problem is we're dealing with an x and a y here. So normally on a first derivative test, right, we would draw a number line, we'd mark our critical value, and we'd choose test values on either side to see what the behavior was, to see whether it was going up into down or down into up to determine if it was a max or a min. Well, we don't have that left and right side of this point here, so the first derivative test is really off the table. That leads us to the other way that we can find relative maxes and mins, and that's going to be to use a second derivative test. I'm just going to call it a second D test. What we know is if we take our second derivative and plug your critical value into that, if what you get out of there is a negative value, well, that tells you that the graph is concave down, and the only place you could have a critical value in a concave down section would be at a max. Conversely, if you plug in your critical value to a second derivative and it comes out as a positive number, then we know our graph is concave up, and the only place you could run into a critical value in a concave up section would be if it's happening at a min. So what that tells us for this problem is we're going to be running a second derivative test. We're going to need to find the second derivative of our derivative equation up here. Once we do that, we will plug in our critical value and we will see whether or not our second derivative is positive or negative. And that's going to tell us whether we have a max or a min. So let's begin this fun process. So we come up here. We have the original derivative given to us. So even if you didn't find the derivative yourself on part A, you would still want to use this as the derivative since they gave it to you in the problem. To find this derivative, this is going to be more implicit differentiation like we did back on part A here. To do implicit differentiation, you're going to wrap this thing in a set of parentheses and you're going to ddx this. My saying when I do implicit differentiation is every time I take a derivative, I get extra stuff. And what that extra stuff always looks like is it'll be d, and then kind of envision there being this little box on top over dx. And what you'll do is you'll fill that box in with whatever the letter is of what you took the derivative of. So if you take the derivative of a y term, it would be dy dx. If it's an x term, it would be dx dx. So let's start working our way through this. The first part here is the easy part. The derivative of our first derivative gives us our second derivative. So this would be d2y over dx2. And then that's going to equal, and then as we come over here, here's where the real fun begins. Remember that even when you're doing implicit differentiation, chain rule, product rule, quotient rule, all those rules still apply. And so what we've got going on in front of us right now is we have two chunks being divided. And so what that means for us is that we need to apply the quotient rule here to start with. So my quotient rule is saying my recipe that I use goes low, d high, minus high, d low, and then all of that is over the low squared. So I would label the top piece the high piece, the bottom piece the low piece, and then I would just break those out into their own bite-sized little math problems. So I would say, okay, the high is going to be that top piece, which is y times the cosine of x. The low is going to be the 4y minus the sine of x. And now I have to look and find the derivatives of those individual chunks. That's how I get what I call the d high and the d low. So coming through here, again, we're still doing implicit differentiation. We're essentially ddxing this thing. So coming through this, oh crazy, we run into two things being multiplied. Well, when we've got two things being multiplied, that means we need to apply the product rule. So the product rule saying that I use goes fg prime plus gf prime. I label one chunk the f piece, the other chunk the g piece, and then I run through my rule here. And when we're doing this, it's when we hit that g prime and that f prime that we are taking a derivative and we get that extra stuff that I was talking about. So following my rule, it says first go grab the f. All right, that would be y. Multiply that by g prime. The derivative of cosine, that's a special case. You just have to have that memorized. You got to have all your trig derivatives memorized for this test. The derivative of cosine is negative sine. So then this would be negative sine of x. I took the derivative of an x, so I get a dx dx. Plus, go grab the g piece, which would be cosine of x, and multiply that by the f prime. The derivative of y would be 1. I took the derivative of a y, so I get a dy dx. So that thing is huge and gets into the way of my nice pretty formatting here, but that's the derivative of our high, and now we'll go do the same thing with our d low here. So again, this is still implicit differentiation. You're still ddxing this. So I take the derivative of 4y. The derivative of 4y would be 4. I took the derivative of a y, so I get a dy dx. Going on to the next piece, I get minus the derivative of sine would be cosine. Again, that's one of our special case rules that we just have to have memorized. If f of x is the sine of x, the derivative of sine is cosine. So then we get cosine of x, took the derivative of an x, so I get a dx dx. So now, after all of that huge mess, we have to put it all back together now, following our quotient rule. So we follow this rule. The rule for the quotient rule says first go grab the low piece. So I go grab the low piece. 4y minus the sine of x. Multiply that by the d high, which was this huge thing here. One thing you can do as you come through is kind of clean this thing up. The dx over dx, they cancel each other out. We also don't need that 1. And I'm going to slide that negative sign to the front of the y because that's like a negative 1. So this would have been negative y times the sine of x plus the cosine of x times dy dx. Then we're going to do minus, go grab the high piece. So we go grab the high piece, which would be y times the cosine of x. And we multiply that by our d low, which would be this piece here. So that's going to be 4 dy dx minus the cosine of x. And then again, we can cancel out dx over dx. And then all of that is over the low squared. So all over 4y minus the sine of x squared. So we now have our second derivative, and what we have to do with that second derivative is we need to plug in our critical value to that. So we come back through and we pop in our critical value. So we've got an x is pi over 2 and y is 2. So working our way through this, our d2y over dx2, we don't have to solve anything, we just need to start plugging in now. So I get out of the top, I get 4, and then y is the 2 from our critical point, minus the sine of x is the pi over 2, again from our critical point. Then we'll multiply that by negative, and we've got a y there, so that y is going to be our 2. And then that'll be times the sine of pi over 2, plus we now want the cosine of our x value, so the cosine of pi over 2. And here's where we run into the dy dx. Well, remember, this is a critical value. You already did that work. You know what dy dx equals because you solved that out. You found where we had a horizontal tangent line. That was this value. We know dy dx at pi over 2. That's going to equal 0 because what we had was a critical value. So we can plug in 0 now everywhere we see that dy dx. Then we keep moving on down the road. We get minus our y value, which is again 2, times the cosine of our x value, which is pi over 2, times 4, oh my goodness, are we going to have enough room? dy dx, again, that we already know what that is 0 minus, and then we got the cosine, can I squeeze it in? Barely, cosine of pi over 2, and then all of that is over 4 times y, which is 2, minus the sine of x, which is pi over 2, and all of that is squared. I hope you had a lot of room on your paper when you were doing this. It's always frustrating when they make these things so long because it's just a lot to manage. But that's what we're looking at, and now we're just going to kind of, again, start taking this down a chunk at a time, remembering that what we're really looking for here is really just whether it's positive or negative. So we get our d2y over dx2 is going to equal, starting off here, I get 4 times 2 is 8 minus the sine of pi over 2. So here's where we got to hit up our unit circle again. So the unit circle is, the corner parts are where we're talking here. So this time we're talking strictly about pi over 2 on all of our values here. So at pi over 2, our values there are 0 and 1. Remember that the cosine value is always what gives us our x value, and the sine value is always what gives us our y value. So when we want the sine of pi over 2, we're looking for the y value at pi over 2, which would be 1. So then out of there we get 1. And then moving down the road, we get negative 2 times the sine of pi over 2. We just found that out. That was 1. Plus, now this time we're looking at the cosine of pi over 2. The cosine of pi over 2 would be the x value here. So the x value at cosine of pi over 2 would be 0. So then we get a 0 out from that, which technically we kind of knew it was going to be 0 anyways because we were multiplying by that 0. Then we get minus 2 cosine of pi over 2. We just figured that out. That's 0. And the nice part about having that 0 out in front is you really know that the rest of this stuff, 4 times 0 and then times again, cosine of pi over 2 is 0. That whole back piece right there, 0 times anything is going to give us 0. And then on the bottom, we work out, we've got 4 times 2 is 8 minus the sine of pi over 2 we know is 1, and all of that is squared. And continuing to work through this is one of those battles of wills. Like, do you have the strength to make it through all of this algebra and all of this notation? So we get 8 minus 1 is 7. Inside here we have negative 2 plus 0 is going to get us negative 2. And then that back piece zeroed out. On the bottom, we now have 8 minus 1 is 7 squared. So out of there, we end up with negative 14 over 49. You don't need to worry about simplifying this thing down. All you need to know out of this is that this is negative. So we know that that is less than 0. So our conclusion here is d2y, our second derivative, evaluated at our critical value of pi over 2 comma 2, that's going to equal a negative 14 over 49. That tells us that this is concave down, and the only place we could have a critical value, our critical value that we knew in a concave down section, is if we are looking at a max. And so our final conclusion on this is that pi over 2 comma 2 would end up being a relative max. So a lot going on here, a lot of notation to keep track of. You just got to slowly and methodically make your way through it, and you'll get to that final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.